Okay, it's 10 a.m. CDT. So welcome to the DMM working group. I'm Shri Gundavali, and I have a new co-chair, Satoru. Satoru, you want to introduce yourself?
Hello everyone, this is Satoru Matsushima. I will do my best. Thank you.
Thank you, Satoru. Satoru has done some outstanding work over the years. He's very well respected, and I'm very happy to have him as the co-chair. And before we start the meeting, few things. So please be aware of the IPR policy. This meeting is run under some IPR rules and regulations, right? So with respect to IPR policy, this is documented in RFC 5378 and RFC 3979. So when starting a presentation, please declare any IPR that you have. And for section 5 of RFC 3978-4748. And if you're asking questions and if you're aware of any IPR policy, please state the same. You're bound by these requirements. Now, second thing is essentially note well. Please be aware of the IPR policies with respect to how the code and conduct. That's one thing. And finally, some blue sheets. Please everybody, if you can. Yeah. And we need two note takers. Hey, Suresh, welcome. Or AD Suresh is also there. We need two note takers. Anybody? John, thank you. One more, please. Any volunteer? Any note taker? Okay, thank you, Dave. And on the Jabber, we have 7 people on the Jabber, right? And the link to the working group is, on the posted here, and the next is the agenda. It's on the site as well. And couple of things. I think a quick review of where we are. We have the first document. These are the working group documents. A quick status update on where we are. First one is the user plane protocol and architectural analysis on 3GPP 5G system, right? This is 5G U plane analysis. It's a 0.2 version. I think I've seen some discussions in the mailer, and I think it's progressing. It's still in the early stages, right? But overall, the authors are serious, and there's a good amount of work is happening, right? I think, yeah, working on participation, we need reviews, but I think it's okay so far. The reviews are okay on this. The next document is segment routing, IPv6 for SRv6 for mobile user plane. This is the SRv6 mobile user plane 05 version of the document. This is almost, coming to a closure, right? I think, we have for both these documents, there's a scheduled, presentation slot. You're going to hear more, more on these documents. Now, moving on to the FPC document. Earlier, FPC document was one, but last time there was a view that the FPC document should be split into the Yang model should be, because many people felt this is a document in the size of 200 pages is unreadable, right? That is the feedback. Even I tried to reach out for some reviewers to review this, but the mere size of the document we got, it's not going anywhere. So we chose, after our discussions with AD, and Suresh.
Yeah, so Suresh Krishnan. So this is kind of like I kind of pushed on this a little bit, because I think the potential review pool for these two are different, and I think somebody can look at the document with a mobility perspective, right, and then sign off on it, and then we can see if the Yang model matches this.
Right.
We can do that in the group, okay. But somebody can look for the Yang best practices separately. And like, I was trying to get a review from the CT chair, which is Lionel. So like he's just like, it's just too big for somebody to read this thing, right? And I don't think everybody has to read the Yang module, right? Like the idea is to do the review separately, see if the Yang is well formed in one way and well designed. And all we have to do is check if what we want to do is good and if the Yang model matches. So that's like 3 different things we can do independently. That's kind of why I was trying to push for this.
Okay. Yeah, that makes sense, Suresh. Yeah. Thank you. I think,
And for the minutes, like one of the things we decided was that the Yang module will become a working group document with no further call. So that's something I signed off on. So that's just like put it in the minutes that it's a working group document.
Yeah, absolutely. I think based on our discussions last time, that step already took place. Yeah. So essentially the FPC document now got split into 2 documents. One is the base specification, and the Yang part is separate, which is the Yang for protocol for FPC. Now that the document size are somewhat manageable and each with a different focus, right? Somebody with some understanding, familiar with the Yang structure semantics, they'll be able to review the Yang thing with more from the point of view of the semantics and all of that. So this is a good move in our opinion. So now hopefully we should be able to move them forward, right? The FPC, unfortunately, the FPC document in the process, has to be republished because it also has the Yang stuff that needs to be, I think we are waiting for Charlie to, and authors to, post in the version. So this is these are the 4 of the documents. Now, the other 3 other documents which have completed working group last call. One is the distributed mobility anchoring and the proximal IPv6 extensions for DMM. Both are, we have completed we have sent it to Suresh, the or AD. It's in the ADQ. Yeah, Suresh. Yeah.
Yeah, Suresh. So I was hoping to get this done before the IETF, but it just came in just a bit too late for me to review it.
Okay.
So I hope to get this, both of them out of my queue probably within the next 2 weeks.
Okay.
At least the AD eval out.
Okay.
And hopefully there's not much to fix, but once it's done, I'll send it to the. So I'm not going to wait for an in-depth review on this because I think like I can take care of this like fully myself. So AD eval, any changes is required, and then it goes to IETF last call.
Sure.
And the on-demand mobility is just waiting some discuss resolution. So I managed to have some discussions on that. There's probably something to do, but it's not clear what it is. So I'll try to like sit down with like Danny, hopefully, probably like discuss like some ways to address things. But I probably won't be able to do it till Friday.
Okay.
So I do want to get this document done because it's almost done. So it's like very close to being finished. So I'll try to get this out very quickly. But I don't think it's like too much working group action required on this because I think the changes are going to be pretty minor, like editorial kind of things.
So it's just one discuss pending as far as I know. Is it?
I think it's 2.
2 discuss
Danny?
positions.
1 left? Okay.
One.
So
Okay.
because like I've been. Right, but I'm not sure if she cleared already, but I'll just make sure on Friday if like whatever is required is done. So before you go home, I can tell you like if there's any steps for you.
Okay, thanks, Suresh. So yeah. So that is the status of all the working group documents. Next is our first presentation, right? Just let's make sure. This is the SRv6 mobile user plane, Satoru-san. Just 1 second. Just. Yeah, it's the location.
No, actually, I'm going to present this service mobile.
Yeah, so oops, sorry. I thought. Sorry. The order I messed up. This one, right? Oh, again. So what am I doing? Sorry. Okay. Use a plane. This.
No.
Shit. Sorry. Okay.
I try.
Third one, right? Okay. Now here.
Sorry, yes.
Yeah. Okay. Let me click. Yeah. Okay. And this one.
Also, yes.
Full screen mode. Okay.
Presentation.
It's in full screen mode.
How is work?
Present. Cool. Sorry. Okay.
Good morning, everyone. I'm Satoru Matsushima. I'm going to present a basic mobile user plane update for 5th version. Oh.
Nope. Turn it on. 4 on, 4 off. Turn it on. Turn it on.
I think no battery.
Oh, no battery. Okay. All right.
Oh.
Okay, I'll do it.
Okay, here's a summary of the update from 4th version to 5th version. The naming change, as I commented on the mailing list, we took the naming for the translation function from IPv4 GTP to SRv6 from TM TMAP to TM GTP4D. It is much clearer what the function looks like. And next one is to reflect the comment on the mailing list, which the UE session is unclear. So we also to take the terminology of PDU session instead. So naming change is done. So next is stateless mapping rule have been changed to reflect the new format to adopt a new argument to put the mobility session information in the SIT. So in detail, the SIT format of the MGTP6 and 4E in the direction of the SRv6 to GTPU, the aligned format of the arg.mob session. That's one. The next one is the last SIT in the outgoing packet of the MGTP6D in the direction of the GTP to SRv6 in the IPv6 case, and GTP4 case are also aligned with the argument format. The pseudocode of the MGTP6D and GTP4D is updated to make sure the PD session type for the especially V4, V6 session. The original, next one is original IPv4 source address is preserved in the IPv6 source address. In the previous version, the source address is embedded on the SIT, but this update makes the source address to be in the source address of the IPv6 packet. That's a summary of the update in this version.
Yeah. Okay. Next slide.
Thank you. So, as you may know, we did the hackathon project to implement some of the future, almost the future of the SRv6 mobile user plane by using the BPP, the FIDO project. Now all GTPU interworking function has been implemented by using this. So the implementation aligned already the new mapping rule. The new all interworking function means that the GTP6E and D and GTP4 and E and GTP4.D. So during the hackathon, we figure out that we need one more function to support drop-in mode. So drop-in mode is not described this document, but let me explain a little bit. The idea is the packet comes into the GDP node encaps the packet by a GDP header, then SRv6 node translates GDP packet to SRv6. This is the normal case, but in drop-in mode, that's the SRv6 packet translates again to the GTPU. That's introduced SRv6 user plane with no impact to the GTP, the path end to end. So in the middle of the path, SRv6 the user plane can be manipulated by the function or T path by the operator's policy. So that's the one of the things we achieved to implement or figure out. So all of the running code are available already in the GitHub repo. Please see the code and play with that. And your feedback is really highly appreciated.
So, Suresh Krishnan. So, just a question, Satara-san. Like, so the drop-in scenario is like, what is the use case? Is it for like roaming or like for hierarchical stuff? Like, what are you thinking of?
One of the use case is to put the function. It's not the CPP network function. It will be kind of the arbitral function, like so-called like the function deploying so far is N6 interface beyond that. But once the packet translates to SRv6, all of the function deployed so far in the N6 is located on the in the middle of the path of the mobility path. That would be one idea. Another is, of course, the traffic engine. It's easy to see. And make sure the routing differentiation based on the seed instead of the endpoint of a GTPU, which does no information to follow the slicing or QFI or something.
Right. Like, no, I was more worried about the conversion back to GTP. So, like, I understand why it's getting converted, right? Like, but I'm just worried about why because the N6, you can just pump out the IP packet, right? Right. Like, so I'm just wondering, like, what is the use case? So the two things I thought of was like either you're having a hierarchical UPF, right? Like, because like the other one might be a GTP UPF, right? And the second one was roaming. Those are the two things I was thinking of. Is that like similar to what you think?
Yes.
Okay. And the second question is, are you going to add this into the draft as well as a scenario?
That's the next question.
Okay. I think it's reasonable personally. No AD hat, but I think it's reasonable.
Okay. So next, please. So I'd like to clarify the all major and minor, including minor comment from the mailing list. So to make sure all of the comment will be appropriately reflected to the draft. So in the end of this work, I would like to ask the working group last call. So let's see the major comment. So first one is drop-in mode, as we talked. So what we received from the mailing list is, could we add the drop-in mode? I mean, GTP to SRv6 to GTP translation again, which Smith has presented in IETF103. So I think we can have discussion like the drop-in mode almost covered by the existing function, except the one GTP6D.di, because the GTP6D doesn't put the endpoint of the GTPU, but to back the GTP header from the SRv6 to GTP. So for the GTP6 case, we need the original endpoint address of GTPU. So that address should be preserved at the end the last seed in the SR header. So that's why we need to define the new function to cover this drop-in mode. So the other point is whether we preserve the UDP source port as original to make sure the transparency of the original GTP packet. I don't think we need to preserve original UDP source port because the GTPU is one of the unidirectional tunneling protocol. It's not needed to define the tunneling session by using source port, but it makes sure that some level of the load balancing by using source port entropy, but it not be requirement to keep the original source port transparent. We can recalculate the hash to put the UDP source address. So that's the two discussion here. So question here to you is, does this draft need to describe drop-in mode, or would it be better? So I think if certain number of the people think drop-in mode is useful or reasonable, I would happy to work on that. And also, if someone doesn't understand or doesn't find any goodness to cover the drop-in mode, I think we can keep the draft as it is. So please comment on that now or after the presentation. Okay.
I think myself, the Shri chair hat off. I think it makes sense to describe it.
Okay. Good. Okay. Let's take that. And next one, please. Next slide, please. So next one is the argument, argmove session. So the comment is when it is required to use argmove session, when would be a seed need this information and what it would be. So discussion here is unchanged G-node B scenario should be a case, at least the argmove session to be used, because the end-to-end SRv6 user plane case are not necessary to use argmove session if the seed can indicate the QS flow and session. But in case that one seed aggregates the multiple PDU session, argmove session also help to avoid a variety of seed format. That's discussion. So here we propose the resolution is add text to clarified argmove session is required in case that one seed aggregate multiple PDU session. That's our proposal. Please next slide. So next one is also the argmove session. So the comment from mailing list is, please elaborate this a bit more, since the SRv6 function is likely not to be instantiated per PDU session. Argmove session helps the UPF to perform the function which require per QFI and or per PDU session granularity. So this discussion is while seed aggregate multiple PDU session belong to the same policy, argmove session helps to indicate which PDU session packet will apply that policy, such as usage, report, or QoS, etc. So proposed resolution here is to add some text like, in case that one seed aggregate multiple PDU session to the above sentence. Above sentence means since the SRv6 function is likely not to be instantiated, blah, blah, blah. So this is third point. So next, please. Next slide, please. So the next point is SR policy in the section 5.3.1, interworking with SRv6 GTP. The comment is, how does the SR gateway run seed list to a DA, a destination address? This must be per session, doesn't it? So discussion here is, in this case, the DA of receiving GTP packet is a seed of the end-to-end GTP6D associated to a seed list described in the section 6.3. This seed can aggregate multiple PDU sessions so that it shouldn't be per session basis. The proposed resolution is to modify the text on the third bullet to align with section 6.3. That's our proposal. So next one, please. So next one is the terminology, the anchor. The comment is, the draft seems to use the term anchor or anchoring quite a lot, but what exactly it means is much unclear. It looks to me that the meaning change during the progression of the text and depends on the context. As it appears to be such key term of the draft, I would recommend that you define it somewhere in this document. Very fair. Discussion 8, I try to find the generic terminology, but during that, I found MAG and LMA would be example in IETF term for the anchor. And of course, the SP gateway and AUPF would be also appropriate term in CGPP. But I couldn't find the generic term to mean the anchor so far. So I also couldn't come up with the exact proposed resolution, but we need to discuss.
So one question on that, right, Satoru-san? If you look at the traditional definition of mobility anchor, and based on our prior work on mobile IPv4, V6, proximal IPv6, anchor is a topological, from routing point of view, it's an anchor of the IP address, right? So is the SRv6 spec, is it changing that fundamental aspect, or is it defining a new behavior, or is it still an IP from the IP point of view? The UE session IP is anchored. That's a topological entry and exit point. Is that the case, or something different is the question?
Thank you. As we already explained that this user plane, SRv6 user plane doesn't depend or assume the specific the architecture of the mobility like SVPP and PMIP. That would be applicable for all of the mobility networking. As that, I think we need to cover not only for IP anchor, but also the access network anchoring, like S gateway and MAG, something like that. So in current terminology in IETF, it doesn't cover the such kind of the access area anchoring. So I'd like to cover that things. But if I try to put some text on the anchoring definition, I try to put some sort of the anchoring means like MAG and LMA in IETF term and SP gateway I and AUPF in CGPP term, something like that.
Right. I think the way I look at it is anchor also anchor doesn't mean it ties to a specific protocol or PMIP or right. I think the way we said was in the past, anchor means the UA's IP address is topologically configured on that node. From the IP point of view, that is for the rest of the world, that IP address belongs to that node, or at least that's the entry point to that for reaching that IP address. Now, LMA is a form of an LMA. When we defined LMA, what we said was LMA is also an IP anchor, or home agent is also an IP anchor. So that's how we put it in. But now I think your definition of IP anchor or whatever in the context of this document, we need to maybe discuss this and see how it fits the existing definition or existing understanding and what we are modifying here.
The confusion we introduce is we use a lot on anchoring, whether it is AMP anchor or access network anchor. So I want to make clear the anchoring in the specific context in each of the section or the use case.
Right. Thanks.
Arashman here from Huawei. Just a quick comment here that regardless of how we see different anchoring points, they're all UPFs in the new 5G stuff. So and this draft is not going to modify the functions of those UPFs. It's kind of creating the data path between these UPFs. The actual function of those UPFs is defined by the 3GPP architecture, and we're not touching any of those. So regardless of whether we're going with the IP anchors or mobility anchors or service anchors, doesn't matter. They're all UPFs to us, and we are all just creating the data path between the UPFs. So one way to probably maneuver around the term anchoring here is just call them UPFs, and then these UPFs could be incarnating different type of functions which cover a whole bunch of anchor points, basically.
But one issue with that approach, right, Arshimit, UPF is a 3GPP term,
Yes.
right? In general, in IETF, we don't have that definition, right? So maybe we can say anything, but as long as we provide a proper definition of what functionally what it is. If somebody looks at it from pure IP point of view, if we can say UPF is so and so, then we are good, right?
So well, let's work after this meeting
Yeah.
and then see whether we can actually find a term. But again, like one way we can actually generalize this is basically the anchor point, to me at least, is a function that we are providing, whether it's a policy enforcement function, whether it's something like that, right? That's a role of anchor point. So
Right.
we don't want to actually go through every single type of anchor that we can find and basically find the use case in this draft.
All right, fair point. Thanks, Arshint. Yeah, Suresh. Yeah.
Yeah, Suresh Krishnan. So one way to get around this is to talk about examples rather than specific terms, right? You can say like, hey, like examples of this functionality are da, right? Like, so we can talk about,
Right.
so I think we kind of talked about this like sometime during the PMIP or mobile IPv6 work, right? We can say, hey, like for example, the PDSN or like GGSN
Right.
kind of thing, right? Or P gateway. So I think that would be like an easy way of like avoiding
Right.
or specifying, but still kind
Right.
of give something for people to anchor their
Right.
this IETF like role to like what they understand in their architecture.
Absolutely. I think in the past also we come across this, right? ASN1 gateway or PDSN or home agent. Yeah, please. Marco.
I think anchor is a well-defined term. It has a specific meaning, and it goes beyond that traffic traverses that particular point to reach UE. So it has more policies for charge event monitoring, whatever. So since we talked about traffic offload function, so that term doesn't hold exactly anymore because not all traffic and packets need to traverse that kind of UE. So in earlier terms of DMM, we also tried to look for alternative technologies and came up with a DPA, which was a data plane anchor,
Right.
data plane node. So
Right.
that could be a data plane node or data plane gateway that terminates GDP and apps segment routing kind of extension headers. So I think we can go around these 3GPP terms
Right.
and but we need a clear definition of how
Right.
we use these terms in the document.
Yeah, that's a good comment. Actually, we did try to capture those definitions in the document, but unfortunately we killed that document. Yeah, Uma.
Hi, my name is Uma. So we come across this when we're writing our document. One of the 3GPP CT4 delegate corrected me on this part. What I would request is a minor comment. Don't change the definition of what 3GPP does in this. We don't have to redefine that stuff. For example, the PDU session anchor, generally the original P gateway, LTE deployments, and the UPF, as a lot of folks said. One is the IP address assignment to the UE, and also bitrate enforcement, lawful intercept, all this stuff happens there.
Right.
And
Right.
the new functionality in the 5G, which is introduced, DP, UPF, and ULCL UPF, they don't do that, right? So in that sense, 3GPP has particular way of defining it. If you're talking about UPF, we should stick to that. And if it is possible, refer to a particular 3GPP document so that this document would be consistent with 3GPP definition.
Okay, thanks, Uma. Any other comments? I think, but you have enough to
Yeah,
take this.
thank
far.
you.
Yeah. Okay.
So next one is the GTP message support. So the comment is, we assume message type is GTP message TPDU and message type number is 255 and cannot transfer GTP ping, which use GTP message echo message type 1 and GTP message echo reply message type 2. Should we add capability to translate GTP echo to ICMP6 or add store GTP message type in some place? So discussion, whether we will cover GTP message in this draft or not, while we agree to cover end marker is one of type of the GTP message in another document. So proposed resolution here is to cover GTP message including end marker in another document. Yes, I really appreciate the someone volunteer to write down that document.
Yeah, that, maybe with chair at hand, I think that makes sense. I think, and I always said, that's a bigger work item, or at least, that requires some focus. I think we should keep it out of this document.
So next slide, please. So we done the major point, and we categorize the rest of the comment as minor, but someone see the major or not. But let's clarify. The minor comment in section 511, uplink packet flow in traditional mode. The comment is, what is the specific table where the lookup is to be done? Does this mean that to support mobile user plane, there need to be an additional lookup table? The discussion here is this mentioned typical behavior which lookup fib to find next stop, but very usual. So proposed resolution is to keep the current text.
Okay.
Next one, please. In section 512, downlink packet flow in traditional mode. In this case, you probably need an additional lookup table to map the destination address of the UE with address seed with the G node B. The discussion is there's no need to look up the UE address at all. So that seed encodes itself the session ID. So proposed resolution is keep the current text. That's really straightforward. So next one, please. Section 521, uplink packet flow in enhanced mode. The comment is, what is address B? Shouldn't it be address Z? Or what is TID used in this case? So discussion here is address Z means actually UE address, yield to mapping with B as the, I forget. It's the seed, and T is a TID. Based on T, we perform a lookup to find the full seed list. So proposed resolution is keep that current text.
Mhm.
Okay. Next slide, please. Section 5.2, enhanced mode. The comment is, how much overhead does the use of multiple seed introduce, and what is the impact to header compression? So discussion here is which each seed has 16 bytes, but we can't state exact size of overhead due to it depends on the amount of the seed used for traffic engineering or service programming. When it comes to header compression, SRv6 user plane doesn't impact the lock on radio interface. So proposed resolution is keep the current text.
But one question on this, how is this specific to this work item or the base SRv6 header?
No.
Neither. Okay.
Of course, maybe in the Spring Working Group, in this time, I discussed some sort of the seed compression solution. We can utilize that. So next one is section 5311, uplink packet flow in interworking with IPv6 GTP. The comment is there's one instance of the MGTP6D seed per PDU type. How is the PDU type inbound by use of TID? The discussion here is DTP6D seed would be instantiated per PDU session type basis. The proposed resolution is keep the current text.
Okay.
The next slide, please. Section 5312, downlink packet flow in interworking with IPv6 GTP. The comment is when the packet destined to A arrive at the UPF2, the UPF2 perform a lookup in the table associated to A. How is this table populated? By the mobility signaling or something. The discussion here is N4 signaling could be one solution. Others could be CLI, netconf, resconf to configure the table. IP routing protocol such as BGP, for example, to advertise and install the entry in the table. So the proposed resolution is keep the current text, I think.
Yeah, I'm trying to see if I can scroll it down. No, I cannot. Okay. But there's not, maybe, yeah, if you can read it, that's fine. Move to the next slide.
Yep. So we close to end. 5313, scalability of interworking with GTP6. TEID is scoped by the GNode B and UPF2. Same TEID may appear for different GNode Bs. How do GTP echo works for these cases? Discussion is, as the last seed indicate GNode B address, it makes clear that GNode B scope in which the TEID is kept unique. So proposed resolution is keep the current text. Okay. So end map in section 6.2 is a mapping table used at the step 1, mobile user plane specific, or is it general for any SRv6? If only for mobile user plane, how is that populated? Discussion is the segment can be used generically for any SR-basic functionality. However, in the context of mobility, a unique end map segment will be instantiated. The proposed solution is how to populate the mapping table is out of scope. So next one, I think it will be last one. It's also end map in section 6.2. The comment is, what is segment list in line 3? Is it segment list of the original packet, or is it new segment list of the end map function? The discussion is, segment list here in pseudocode should be seedless. The new mapped seed is bound to the seed list. The proposed resolution is add some text to clarify the above. Okay.
Okay.
So that's all we clarified. We'd like to clarify the comment and the resolution. So our next step is working group last call after when we reflect the substantial resolution to the draft. And also we need implementation. As I mentioned at the first, we already have a BPP code and also the P4 code as well by Kentaro. But we need more implementation. And we continue the hackathon project on the next IETF meeting. So if you are interested in to hackathon to be joined, please come. Thank you. That's all.
Thank you, Satoru-san. I think looks like this is going on the right track. Thank you so much. Okay, next blue sheets. Everybody signed the blue sheets. Okay. Next one is transport network aware mobility for 5G. John or Uma.
First two slides are present.
Okay, sure. Let me bring it up. John, sure. Okay, I think that's not working. Just let us know. Yeah.
Oh, this doesn't work? Okay.
Oh, something.
Hello, everybody. My name is Uma. I'm going to talk about transport network aware mobility for 5G. We're going to talk about the new addition we made to the original proposal. So first, I will just lay out what problem that is being solved, and what the new addition that we made will be talked by my colleague John. Okay, so in 5G, we all know that various SST modes have been introduced, but there is no clear mapping function. So the first thing is with the underlying slices, transport network is not factored because 3GPP will focus mostly on the RAN, and the core network, transport network, is the IETF. But in some scenarios, in non-mobility and mobility cases, for the underlying, for end-to-end slicing functionality, underlying transport need to be factored. Let's say, for example, non-mobility cases, if you are sending a PDU session for the slice, you need to make sure that SLA guarantees for the end-to-end has to be observed, whether the transport network will give that or not, that need to be factored. And during mobility, from G node B to G node B or from UPF to UPF, you need to make sure that transport network also offer the same QoS characteristics for the end-to-end budget need to be factored. So this is the missing part. So how to address this is being described here. There are two approaches described. The second approach is added recently by John. And the second aspect that what we're discussing is there is no clear standard mapping function to map this RAN and core network to the transport. So there are various ways for slicing, early slicing solutions in 2016 for the LTE networks. There are ways people are used to do this. There are only two barriers there. How they map to the PDU sessions to the underlying transport. There are various ways people are doing in actual deployments. So we were thinking to do a standardized mapping, which is applicable to 5G also, because a lot of parameters are changed and the QFI is inside the GTPU extension header. So creating, as I said, creating a reference architecture to integrate the transport backhaul network in 5G service-based architecture. So this integration will help you get the transport network functions exposed to the mobility functions. If you want the mobility functions to other network functions in the 5G control plane, if you want the transport functionality, whether this particular transport slice can give this much QoS or this much latency, that can be based on that, the decisions can be made. So, and as we said, the providing clear mapping function to integrate PDU sessions to the underlying transport. Also, this describes a new path routing mechanism that is called preferred path routing. This is like any other TE mechanism that is there in the IETF right now, right from RSVP TE we have last 20 years, and the SRMPLS or SRV6 today. Of course, SRV6 can do much more things than pure underlay transport. It can do service mapping also, like Sutara explained, where it can be replacing GTP. But traditionally, transport traffic engineering do only the underlay transport traffic engineering, that is like RSVP, SRMPLS. So PPR is a new transport mechanism where it can do path steering without any overhead. And it also additional benefits PPR brings in, and how this fits into the 5G mobility has been explained in this document. That is to validate the reference architecture we put forth, how this mechanism can be used with PPR. But however, the reference architecture put forth can be applied to any TE technology existing in the IETF, from RSVP TE to SRMPLS to SRV6 as a pure transport underlay, not the service programming. The pure transport underlay SRV6 can be used. So that is explained here.
So one question, right, for my own understanding, just curiosity. Is this, was this presented in 3GPP or any of the SDO orgs?
Sorry?
Was this presented in 3GPP or is this 3GPP reviewing this?
No, it's not presented in 3GPP. One of the CT4 delegate in version 2, he had significant modifications to the text, and he was a co-author now. So it was, but it's an IETF document. It's not presented to 3GPP.
Just curiosity, like I said, yeah, fine. Yeah.
Also, this proposal doesn't remove GTP. As we said that this is an underlay functionality. It doesn't touch the overlays like GTP. Whatever the GTP it has functionality it does. But SRV6, even though we discuss here, this is only an underlay transport, not service.
Hi, Oma. Dave Allen here. Can you elaborate on what you mean by provide a clear mapping function? Like, are you defining an API or?
The map.
Just what are you discussing?
Okay, the mapping function is when a packet hits at the G node B or the UPF, what needs to be done to map this to the underlying transport. Let's say if I'm using RSVP TE tunnel, what needs to be done for the PDU session to map to this RSVP TE tunnel? Yes, yes. That's it. The changes, the major change what we introduced was we come up with one approach first in the first 3 sections or first 3 versions. Then later on, John took it from the different point of view, and he said that we have to minimize the changes in the architecture. So we talking about this, but these are unresolved issues. That's why we want to expose this, and we want to eventually merge these 2 approaches into one approach. Eventually, that's where we ask for working group adoption. We are not ready yet.
Okay. Oh, yeah.
I'm from DHS. I have a question for you. Is this going to touch the MPLS layer, or is it?
Yeah, so it doesn't touch MPLS layer. One of the TE technologies, we try to do whatever the IETF has developed, so many TE technologies, right from RSVP TE to SRMPLS to SRV6, and the PPR we are working on. We don't want to touch anything there. We were just seeing in the PPR how the reference architecture can be applied to the PPR, the new path routing mechanism we introduced. That's what we are trying to do. We're not changing anything in the SRMPL, SRMPL.
I think what happened is the current effort that we push in GDP is that we use QCI and together with different code point to do the routing. So how that's going to fit into this
Okay. That's great. So QCI is in LTE deployments. That's where exactly in some deployments based on the QCI and QoS functionality mapping is happening. In some cases, people are using GTP. Once the GTP encapsulation happens, UDP source-based mapping are being used. UDP source-based mapping to underlying RSVP TE tunnels or SRMPLS tunnels are being used. There are so many ways people are deploying. We're just trying to see whether we can standardize this. For 5G, there is a QFI field in the GTP header. That's one way to map this QFI to underlying transport. Or there are so many other ways we can do. He's talking about new identifier that can be used to map this clearly. There are so many ways we can do. That's what we're trying to standardize here.
And then the effort is to, are you going to coordinate this with the GGB folks? I mean, this.
Yes. At some point.
You know, sometimes we have a liaison person that basically, you know, present here, the GGB here, and then we have that coordination meeting. I think we could go out to get everyone involved so that we have consistency.
Definitely.
All right, thank you.
Suresh?
Yeah, Suresh Krishnan. So like that's kind of what I was wondering too. I was going to wait till the end of it, like to figure out like what's your next steps going to be, right? Because we're going to have to somehow talk to the 3GPP and see if it fits the needs or whatever. If you're doing this for 3GPP, because it's specifically targeted towards 3GPP, right?
No, it's not specifically targeted
Because
towards
it says 5G, right? Like and like
No, 5G, if 5G PDU session comes as a transport network point of view, how I use my TE tunnel to map to the PDU session, that's what I'm looking into.
right, and the user of that would be like somebody working on the 5G architecture in
Sure,
3GPP, right? So I'm just thinking like, how do we communicate this exists, and how do we find out if this meets their needs, right? And a couple of things, right? Like as like Anne was saying before, right? Like so, what we can do is like send a liaison statement saying there's this work existing, right? But again, like I keep repeating this for a lot of things. Somebody on the 3GPP side needs to do it. You said you're talking to somebody at CT4, right? I think that there's also needs to be work done in 3GPP to include this. And the second, so one of them is the liaison, is something we can do. And the second thing is like what we've done in the past for like previous generations, like LTE. Like what we've done is like we had a dependency list. So there's a dependency list. There's like it used to be a spreadsheet, but now it's like more formal way of like tracking this stuff, where like if 3GPP is interested in this, like it goes into something we track. So we had a coordination meeting. I was there in the meeting. So on Monday, 3GPP IETF coord meeting. So the idea is like this goes on the dependency list. So like 3GPP knows the status of this, and we also know like if 3GPP is interested. I think that's really the interesting thing.
That would be really helpful.
So that's independent from like what happens in IETF. But if you really want something to happen in 3GPP connected to this, we need to do these steps.
Definitely. Thank you.
Yeah, that's the reason why I was asking Uma if 3GPP looked at it. or if you guys-
But I just want to say one thing. We are still not ready yet. We have still two approaches. We want to resolve this. Maybe next version we will be in the stage where we can expose it to further.
That's fine, Uma. I think John wanted to say
Yeah, I
something.
want to add something. So just to add to what you're saying, in 3GPP itself, there are multiple groups we need to consider. There's SA5 from a management context that is pretty much in line with some of the interfaces here.
Sounds good.
The SA2 work on the architecture, those folks don't think that anything is needed at this point.
That's fine. Like
So there's
we can
multiple.
put a wide distribution list. Like if you tell me this is something we want to send, the working group agrees on what's the content of this liaison statement, right?
Yeah.
I can ship it off to multiple people, right?
Yeah.
So Lionel is the CT chair. So like SA, like I think probably I had to go through Gonzalo, who's like liaison to 3GPP, not specifically. We don't have a specific person to talk to in the SA groups. But I can ship it off to like a wide distribution list. Whoever is potentially interested, ship it off to them. If they say nothing, a lot of times they say nothing, that's okay. But the idea is like to be cautious and say like send it to the largest distribution list.
Overall, I kind of agree with what Uma is saying, is that we should probably try to coordinate a few things and then ship it to 3GPP.
That's
We're
fine.
trying to limit the number of any overlap with 3GPP, trying to make it clear that it's work that IETF should do, and that's the part that we're trying to do.
Yeah, that's a goal, is to minimize the architectural changes. No architectural changes is our goal, but at the end of the day, they need to know that what we are trying to do here,
Right.
because it is related to their technology eventually.
Right. And my point was like it's better to do this earlier than later. But if you think it's later is better, that's okay. Like I cannot tell you to do. You're the draft authors, right? But what I'm saying is like it's better to like start this up early, because like the 3GPP process can happen in parallel, because there's probably like a 3-month delay from which when we start something, it heads to 3GPP. So we had to go through a meeting cycle. I had to work on the liaison, let's ship it off. And there's like a 3GPP meeting cycle before somebody looks at it, right? So whenever you're ready, you talk to the
Thank
chair.
you. This is really valuable. But for the working groups in the 3GPP side, John also mentioned, the probable working group is SA2, CT4, and SF5. These 3 working groups maybe.
That's fine. Like what I'm saying is like when you're ready to like take this one step further, you go talk to Sri Satar-san and Dapeng, right? And they pull the working group consensus and they ship it off to me, and I do the stuff, because there's like a process for this and it all takes time, right? So
Thank you.
Thanks.
Okay, it's continuation, right, John? Yeah.
Yes. So I'll try to continue from where Uma left off. So this is mainly addressing the changes that we added into the revision 4. We have some time, right, Trey?
Please. Yeah.
Okay. So then I guess the main things that are changed are in chapter 2.2, and let me identify what exactly that is. So it's a mapping between the 3GPP 5G slices to the transport slices. Elaborating on that a little bit. So the 5G QoS and slice information that's carried in NSSAI are what is offered in the PDU context to a UE. That does not have a direct relation to what a transport network provides. A transport network's clients are the 3GPP operators. So they're offering slice services to a 3GPP operator, whereas a 3GPP PDU session are slice offers to a UE. And these have a end-to-end kind of relationship. It's not a one-to-one of any sort. So there definitely needs to be a mapping between these two. Just to take it a little bit further, if you take those segments, for example, if you have an N3 segment, that may be provided by one transport provider and another segment may be provided by another one. Not necessarily, but it could be. Versus if you take the transport provider, they may be serving multiple clients like a mobile operator or a fixed operator, CDN, and so on. So clearly there needs to be a mapping between what's offered in the transport and what a 3GPP provider requests. The point in B is related to, how it was solved partly in 4G. And I think Omar touched on this, or this discussion came up with the MPLS question too. Part of it is that what we're trying to map through an identifier here was probably solved within a node, which terminated the 3GPP as well as a transport function, like an MPLS. So the translation was done within a node and it was okay. But as was identified in Shunsaka, Homas, and the draft on user plane analysis, if the nodes are distinct, then there needs to be a means by which to convey this. And I think point C is that between the two 5G functions, it may cross multiple layer 2 networks. It could be that the UPF is on a server card that crosses a data center network and then onto a backhaul network. So, we need a reliable means to convey this information.
So any examples of the L2 issues, John, just for clarity?
Yeah, I guess the L2 issue would be, for example, if we put, let's say, a VLAN or something like that in a data center, what would it mean in a backhaul network? We'd need to have explicit translations for all L2s to all other L2s, or at least the popular L2s. So that's much cleaner, is to have a means by which you can convey this information across that segment. And that's what I think we'll try to cover in this point here. We're introducing a mapping identifier or a context. It's a mobile transport network context. I think some of it was described in the previous slide. So it maps a class of service. It should be 5QI on slice and other information that pertains to a 3GPP domain to a slice instance in the transport domain, meaning the functionality that a transport domain can deliver. And that would be a contract between the 3GPP domain and the transport domain. So this is generated by, this mapping can be done ahead of time, not necessarily when a session arrives. And it is generated by the TNF. Now, this function is probably in part of the 3GPP management domain, the NSSFM or some such thing, which we don't want to get into. But I think the SA5, which works on OAM and management, are probably looking to adopt something like ACTN kind of work. So, they have very similar specifications. So that's a point of coordination we'll need in the future. So how it generates or figures out which slides need to be mapped is something that 3GPP should solve. We only say here that there is a mapping that needs to be installed in the transport domain, and it serves as a contract between the two. As mentioned earlier, it's not a one-to-one association because that just would not even scale. And we don't want to add additional delay and processing when we want to establish a session. There must be an estimation of what is needed ahead of each individual session establishment. And of course, we want an identifier that scales. So the way this one scales is ON square with respect to the number of sites, but not, and that N square is much lower than the number of flows. So as an example, if we have 3 traffic classes and N sites, and 25 sites, then we need only about 900. That's just an example in a small area, let's say, which would be much smaller than hundreds of thousands of flows. Okay. So this figure is trying to show both the 3GPP functions and the transport functions. Everything in that blue, not a box, but horseshoe-like box is part of 3GPP functions. And I've identified 3 steps. So I'll try to go into sequence to say what happens. It's roughly in time sequence also, but not exactly because there are a couple of control loops. So the TNF, as we described earlier, may be part of some 3GPP function. We only care about the functionality that it interfaces with an SDN controller here. It defines a contract to say deliver these services. The resources that are needed for a 3GPP slice and identified by this MTNC. The SDN controller programs this in the PE routers as needed. And at that point, the TNF has configured an MTNC as a valid contract between the transport and the mobile network. What we're not showing in the figure is how an SMF or a UPF figures out that it is this MTNC that's needed. That will be part of 3GPP networks and hence not described in detail here. But there's some way that an SMF figures out that this MTNC can be associated to this PDU session. And that's what is then downloaded via the N2 or the N4 interfaces when there's a PDU session establishment. So this is all happening before a traffic flow starts. So at the point that a traffic flow starts, the user plane nodes, and just for reference, that user plane nodes are the G node B and a UPF. So it could be N3 or N9 in this case. They already have the MTNC identifiers. And at that point, the UPF is going to map the MTNC identifier and send it out along with the PDU session packet. The PE router is going to inspect that MTNC identifier and deliver the resources that were configured earlier. And all of that is provisioned as, and one of the techniques we may use is, the PPR that Omar described earlier in terms of how that transport network is going to deliver those resources or, how it is being routed and so on. So those are the 3 steps. First, provisioning the MTNC identifier based on traffic estimates. Secondly, to classify the PDU session packet at the UPNF. And thirdly, the point where the PE router inspects and delivers the resources on path. So this page is a little bit mixed up over there, but I'll talk through this. So one of the problems is if the UPNF adds this identifier, there must be some way to carry it in an IP packet, in each IP packet. And as mentioned earlier, layer 2 ones are not suitable because you may cross multiple networks. GTP extension is really quite bad actually in this case, because it would take a long time to inspect where that MTNC ID is if it is chained in a GTP extension. So actually that's not a good idea. Other extensions like DSCP or IPv6 flow labels are not immutable and hence not suitable also. We are considering a few here. It could be GUE or SRv6, and the flow here shows a GUE extension to add the MTNC ID. So essentially, if you have a packet that the PE router sees with this MTNC ID, it adds the appropriate forwarding information that's needed. I presented this yesterday and tease, and one of the comments we got was to also consider the option of adding a fast ticket. And that is something we will look at. It may have some advantages in terms of inspection, but we'll also have to follow the progress on that.
Okay.
So
So which SDOs will it impact when you guys do this mapping here, right? On the
I think this is an area where the IETF has to do things. We'll have to specify things here. The other things, I suppose, are more informational. Or some other things are more informational. But here, 3GPP or anybody else would have to rely on at least partly IETF specifications.
Okay.
So one of the problem is in the first approach we specified in version 3, we were not trying to change anything in the GTP packet. So we were trying to use the GTP QFI field in the GTP extension header. But the problem is in the scenarios, PE router has to look deep into the GTP extension header to map to the transport tunnel, which is a lot of routers can't do that. So that's why this identifier was brought in. So which will easy for the routers to map quickly to the transport tunnels.
Right. The QFI works on the downstream, and again on the upstream it causes trouble too.
okay.
Yeah. So yeah, that's a point that I missed adding, about the QFI. I think Omar's clarified that to say that, it can provide a mapping between the bearer on the downstream, which may be of some use, but on the upstream you don't have that. Okay. So that's the rationale for all of this.
Eric.
Yes, Eric Klein, just a clarifying question. So the PDU packet here, you say, is a GGPU payload, possibly?
Yes, it is a GDP.
You're further reducing the MTU by 12 more bytes?
Yes, that is a trade-off, yes.
So if somebody says, John, you can just index into the GTPU, is it the decoding part or what is it? What is the challenge?
So I can say that the challenge is simply that transport devices don't look so deep in to figure out on every packet. Or even if it had to, it would be rather expensive to parse some location that's, not a very clear point. I think the parsers are going to be looking at the extension header, and the transport would be able to look at it pretty easily.
Satoru-san.
Satoru Matsushima. So one question on the one of the ideas, the bits and bytes in the header to put the MTSC ID. So I think you already mentioned that the SRv6 had one of the transport of the user plane. But what if you put the MTSC ID in the SRPC user plane part, I mean, the seed can be indicate to the MTSC kind of things.
I think that would absolutely work.
Okay. So,
Yeah.
but I would be concerned that you see the SRV6 as the just transport, not the user plane. So if you can see the
Let me see if I understood your point correctly. I mean, so for example, following the previous picture, just to put it in context. So the MTNC identifiers are programmed at those 2 points, and that is mapped into an SRV6, segment at that node, right? Yeah. So that's not a problem because, I mean, I think the concern we have is we do not want to change any of the existing 3GPP specifications, and doing this would not change any of the 3GPP. So, I mean, we haven't worked a lot into detail on that, but we could explore that.
okay.
I think that's more or less what we have. So at this point, we're looking for comments and suggestions, and we'll have to work, as Uma mentioned, to unify these different approaches. In particular, I think we got some feedback on the slide 7 from Tees, but we'd be happy to get more input. I think Eric gave us some input about the 12 bytes.
So one of the requests for the working group is there any other approach we can think of without modifying packets and putting other identifiers, but is the mapping at the routers also not looking deep into the GTP extension header to get any particular value?
Right.
So is there any other approaches we can do? That's awesome, actually. So for his point, we need not run 4 more bytes for the identifier.
Eric.
Yeah, sorry, I'm way not familiar with enough things here, but is there space in I think you're sending it to the UPF IP?
I'm sorry.
You're sending it to the destination of this thing it's from the Gnode B to the user plane function IP address?
Yeah. I mean,
These are N9 or N3 or which.
Right. So is it possible that the user plane, this UPN?
Yeah, let me just clarify that quickly.
Please.
So each of these functions can be either a Gnode B or a UPF. So in the upstream direction, on an N3, that one may be a Gnode B, and this may be a UPF. So
okay, is it possible that those things could have, instead of individual IP addresses, entire /64s that they own for themselves?
They
So
could.
the routing forwards to them, and they listen essentially to the entire /64, the way a phone does.
So you want to decorate the address with the identifier.
Yeah, put the identifier in the lower part of the.
I think that may
IPv6
be
address.
close to what Uma is suggesting with the PPR.
That's an interesting point. Yeah.
That's a great idea, actually. If IPv6 address is being used as a
Uma.
session anchor.
You might need a mic for.
Yeah, please. Yeah.
So if IPv6 address is used as the session anchors, both Gnode B and UPF, perhaps if /64 can be used, other part can be used to put this identifier. Yes, that's one of the ideas. Yes.
Yeah, because we've
A non-topological.
Google and Facebook and others have done /64 to the data center host. Cell phones have /64s routed to them. Everything that you send, anything in that 64 gets to that phone, whether it keeps it or drops it or whatever.
But what happens if these are IPv4 addresses? That's another.
Why not? I mean,
5G with V4 transport. Okay, that's a fair point. Yeah.
this is traversing the public internet, or this is traversing a series of provider-only sort of
Private.
networks?
Private.
Can you mandate that they're V6?
No,
Okay.
not worldwide.
Then in V6 you can do this, and in V4 you can lose 12 bytes. Just say that. Make it clear.
Let me comment on that's the discussion. When you put the information on the IPv6 to indicate the slice, I think the SMF needs to control the endpoint of the GTP session. So that may touch the change of the CPP architecture. I don't think it be fit current CPP architecture if you put that semantics in IPv6. That's my comment. Okay, so my another comment on this idea. So as long as you mention that it's not touched to the existing, to touching existing architecture to be changed, it must be a much more generic solution to see the packet to map the to the specific slicing. I think it would be not too mobile specific. It's much more general. So if you want to proceed your idea to see the that mapping solution, so I think it would be need to touch to the some sort of the VPN solution working group to propose your idea, because it's kind of the P router behavior to look up the ID to find the appropriate slicing in the core side. So I think that's much more smooth way to proceed your idea.
Thanks. We'd like to work with you then, and I can work with you. There are lots of details in there, and yeah, we'll be happy to do that. Thanks.
Thank you. Thank you, John. Any final, that's it, right? Okay. Yeah, so I think feedback, again, I think it's an interesting topic. We need more discussions, and I think, the number of touch points here, I think SDO feedback and all of that, as Suresh pointed out, right? But I think it's truly the ball is in the author's courts to really, do more work. Yeah. All right, thank you. Next one is, 1 second. Yeah, user plane and architecture analysis on the 3GPP 5G system by Takuya Miyasaka-san. And I think okay, cool. Home is not there, right? Okay, Home-san, okay. Oh, yeah, yes.
You can also do press the full screen in.
Yes.
Yeah, there's a full screen button inside the PDF here in the lower left.
Oh, okay, I see what you're saying. Okay.
No, press the full screen button. It's highlighted, but there you go. And then move the mouse over to the left. There you see a little down.
On the downside.
Up. Just move
Okay, let me
up.
kill that. Okay.
Above plus that.
This one? Oh,
Like that. And then quicker will work.
oh, cool. Thank you.
Thank you. I'm Takuya Miyasaka, and I'm talking about the update of the 5G user plane analysis draft on behalf of these co-authors. So background of this draft is not changed, so I will skip this slide. And the history of this draft, and after the IETF Prague meeting, we update this draft for the reflecting the URLC and also as the PLCP state information at version 002.
Just a little bit far from. Yeah.
Okay.
Thank you. Yeah.
Thank you. And this list shows a major update of this version. And firstly, we added a slice service type on.
Slightly, sorry. Yeah, it's because there's a lot of echo actually. Maybe you can want to just leave it there. Yeah.
Okay.
Yeah, just leave it there and then. Thank you. Sorry. Yeah.
Is it okay?
Yes.
Thank you. So we added a slice service type in the section 4.1, and this SSD is defined by 3GPP, and it represents type of the network slice instance. And 3GPP defines four types of the standard SSD: EMAP, URLC, and MIOT, and BTX. And also we added the PLCP state information and the URLC related requirement and the evaluation aspect. And I will show you the details of these things at the following slides. And this is the PFCP state information. So PFCP is a routing protocol which is utilized between the SMF and UPF. And by using the PFCP protocol, SMF can advertise the user plane configuration to the UPF in order to establish a PDU session for the requested UE. And also in this version, we summarize the 3GPP defined PFCP information element as like IT-friendly young data model like this one. And also by using this kind of data model, so SMF can advertise such kind of packet detection rule and forwarding action rule and QoS enforcement rule and usage reporting rule to the UPF. And after that, UPF can forward the incoming GTPU packet by looking the PDR rule and attach the adequate outer header by looking at the forwarding action rule and to send the adequate node like Gnode B or data network or another UPF. So URLC means ultra reliable, low latency communication. And the specification of the URLC is added as the release 16. And actually, URLC requires a redundant data transfer at the user plane in order to avoid the service disruption in case of a user plane failure. And currently, 23.
Sorry, I have a question on the previous page.
Yeah.
The N4 and PFCP.
Yes.
Are you also considering for N2 interface?
Currently, no.
No, currently, no?
Yes. And go back to the URLC. So currently 23.501 defines the three types of redundant data transfer. And the first one is this one, the redundant user plane path using the dual connectivity. And as you can see from this diagram, so UE established two redundant video sessions to the data network via the master RAN and UPF1, and also via the standby RAN and UPF2. And as for the uplink side communication, UE just replicates the packet and send these replicated packet to the master RAN and the standby RAN. And as for the RAN and UPF just transfers the incoming packet in same way as a normal normal user plane configuration in forwarding. And in this case, so by using such kind of redundant data transfer, if there is issue or the packet loss at the user plane path, like between the master RAN and data network, so this data network can receive the URLC services packet via the redundant standby RAN and UPF2. And as for the downlink side communication, same procedure will happen, and the data network will replication, and also UE will do the elimination. And the second one is the redundant user plane transmission with two N3 tunnels. In this case, there is no independent RAN and UPF node, and there is two N3 tunnel, N3 tunnel 1 and 2 between RAN and UPF nodes. And as for the uplink side communication, the RAN or Gnode B just replicates the incoming packet from UE and send this replicated packet to the N3 tunnel 1 and N3 tunnel 2. And after the UPF receives this packet, and UPF will eliminate the redundant packet and send the packet to the data network via N6 interfaces. So in this case, if there is a packet loss at the transport network path for example, N3 tunnel 1, so we can continue the URLC services by using the N3 tunnel 2. But of course, we need to provide disjoint transport network path for each N3 tunnel. And last one is a redundant user plane transmission with two intermediate UPF and N3 and 9 tunnel. So in this case, as for the replication and elimination procedure, there is no different from the previous one, but there is two redundant intermediate UPF1, UPF2. This is typo, UPF2, and so in this case, for the uplink communication, the LAN or G-Node node just replicates the incoming packet from UE and send this packet to the intermediate UPF1, intermediate UPF2. And as for the intermediate UPF, it just receives a packet from G-Node B and just forwards the PDU session anchor UPF. And as a summary of the URLC, so we summarize such kind of three kind of redundant data transfer in the architectural requirements section in this version. So this as for the variation aspect, so to support such kind of redundant data transfer, so user plane protocol need to indicate the sequence number on the replicated packet. So in order to distinguish these replicated packet at the receiver side. So in this, and as for the GTPU, currently the 3GPP considered to use the GTPU sequence number field, which will be encoded in the basic GTPU header. And in this example case, the UPF will replicate the incoming packet from data network and attach the same sequence number, in this case, sequence number 1, and send the G-Node B. And also, I think this is a complicated scenario, but in case of the third one, we have another consideration. So in this case, as for the sender side, there is no difference from previous one, but there is another consideration on the intermediate UPF. So in case it's a PDU session anchor UPF sends the same replicated packet with the same sequence number, and also so this intermediate UPF must transparently forward the IP packet with same GTPU number to the G-Node B. This is because G-Node B must distinguish that replicated IP flow for the elimination process. So as a summary of the evaluation aspect of the URLC, so candidate user plane protocol need to support the sequence number and also need to support the transparently the sequence number forwarding in case of the intermediate UPF. Okay, so status and next steps. So we added the URLC and we updated the PLCP on this version. So if there is another release 16 based added feature which is related to user plane, please let us know. Okay, that's it. Question, comments?
Quick question for clarification. This is John. The previous slides on these sequence number, are they already standardized, or is it a proposal?
I think this is standard in the 23.501.
But what about the
sorry.
CT4?
No, not, yeah, correct.
Let me follow up. This is the still architecture document only. No stage spec right now.
Still a study item, right? Yeah.
So the sequence number at this point is a study, not a.
It's not decided, I think. Yeah. The CT4 guys have studies another option instead of the sequence number field.
Thank
you.
IETF.
Thank you.
Any other questions? Thank you. I think this is an interesting topic. Working group, yeah, please provide any feedback on this in the mailer.
Thank you.
And next is Marco Levish. Okay. You should be able to operate. Yeah. So this is the, yeah, Mark, go ahead, Mark.
So this is about a draft that we discussed twice during IETFs and also between. And this time we just want to preview a little bit about which kind of activities we do around this work. And our main interest is to apply it to edge computing for automotive use cases. Right. So very briefly about the background, to not steal and repeat what we steal time and repeat what we discussed already. So if we look at the end-to-end communication between UEs, which can go beyond mobile phones and services running in a cloud, there is a 3GPP architecture which has the control plane and user plane functions which can work as session anchor, we discussed at the beginning of this session, and other UPFs which can be used for uplink classification and traffic offload. So on this particular interface, there is a lot of work being done and discussed that's related to the study in 3GPP, and Satoru did a lot of work here to discuss alternatives to GEP. What we are focusing on here is an interface which is not really considered in 3GPP because it just assumes plain PDU routing. So this is the N6 interface between the PDU session anchor and the actual service. So what we want to do is really enable flexible peering of a service and the associated PDU session anchor for a mobile device. And second, to apply policy enforcement points and associated control to this N6 interface to have full control on the steering of the traffic between the session anchor and the associated service. So to focus on this use case, for some vehicles or UEs, let's call them UEs, we may have to move services closer to the vehicle themselves. So this is some mobile edge computing kind of directions. And since the mobiles are attached to a cellular architecture, also these vehicles need to have a UPF serving as PDU session anchor or local breakout point configured. So in this example, we have a UPF which relays traffic to the vehicle from a central cloud, but also from an edge cloud here. So in some cases, in particular, if we want to maintain low latency communication, we have mobility, probably high-speed mobility if we talk about highway roads where cars are moving. So we may need to relocate also the edge cloud. Second, we also need to relocate the associated UPF for efficiency reasons. If we do that, we deviate from the plain routing rules if we want to maintain the UE's IP address. So in that case, we apply the concept that we described in the draft, which is basically having policy enforcement point on the two ends of the N6 interface and control them in a way that we have unambiguous traffic routing between the old or the new anchor and the associated services. So the scope of this draft, first of all, describes the use cases and the operational aspects. Second, we propose how such data plane overlay on the N6 interface can be integrated and aligned with policies in the 5G control plane, because the UPF is under control of the cellular control plane. And in 6, we want to have additional controllers to enforce the routing policies here. So in this draft, we want to look mainly at some architectural and operational aspects and then define the data models that are required on this interface between that controller and the data plane node, and second, between the controller and the 5G control plane. As you can see, we leverage a standard 3GPP function, which is the application function, as a binding element between the 5G control plane and the N6 data plane. So one of the key concepts is that we consider two types of deployments here. So as said, we need policy enforcement points for traffic steering on the two ends of the N6 interface. So one is always aligned with the data network. So we have a data plane node here, which can receive and enforce policies for traffic treatment. On the other side, we have two options. So the UPF may receive the upstream traffic treatment policies directly from the mobile core via the N4 interface. That's what we call tight coupling. Currently, we look more at the loose coupling options for MEC, which you can see later why we do that. And here, basically, we keep the N6 traffic treatment policies and the associated control independent of the mobile core, which has some advantages. So the status of this work is that we started to discuss concepts with some of you before IETF 103 and before. We continued with that on IETF 104, and we received interest and valuable feedback, which has been taken into account in the current version of the draft. So the latest update was unfortunately only before IETF 104. So we describe operational aspects. We support the two different and describe the two different options, loose coupling, tight coupling. And we need to put a bit more energy into elaboration of the mature information model. As we said during the last IETF meeting, we wanted to have an update of the draft with a little bit of brush content because we have a lot of description in, so we want to clean up that and drive the modeling and operational aspect description a bit ahead. Unfortunately, we could not do that, so we don't have an updated draft, but our current focus is more looking into the various aspects of the full system. So that includes ETSI-MEC architecture related stuff, as well as 3GPP related interactions. So secondly, we focus more on experimental prototyping to learn where are additional gaps and where we probably have more things to specify and also have options for standard contributions. So one of the options, or one of the tracks here is that we contributed some of these aspects to ETSI-MEC, and in particular, the loose coupling approach has been discussed and valued there. Last but not least, for the prototyping and trialing, so POC related activities we currently do in one of 3 European Commission granted automotive corridor projects, which is called 5G Carmen. If you want to have a look to that one or talk to me later about the project, please do so. Very briefly, so as you can see, the red part or the orange part is mobile core related functions. So we have the mobile core control plane, the user plane function, and the application function, which in that case we deploy on the Mac Platform Manager, which is part of the green part. So we integrate basically the Mac Platform Manager mainly to access the traffic treatment policies on the Mac platform where the applications are running on top of it. So this is, as you can identify, the N6 interface between UPF and the actual service. And this is what we want to have control. So in that case, it's a local scenario where, for example, the relocation of an application in the Mac platform is required for load balancing or failure reasons. So that's a problem statement that came up in ETSI-MEC. And this is what we can use as a solution here to really relocate the application to a different platform and steer the traffic using the 2 policy enforcement points accordingly. More interestingly, for the vehicle scenario is if we have a moving car. You have a question, John?
John?
Yes, I do. On the previous page, if you have a network in between the application server and the UPF, are you covering the scenario where it's a non-topological route to that UPF?
So if I understood the question right, this is exactly the point why we need the policy enforcement point, because if we move any of the 2 endpoints, either on the application side, which is this case, or on the UPF side, which is the next case, we deviate from standard routes. So we need host routes, which we enforce then on these 2 points here.
And that's done by a policy.
This is done by the policy controllers according to the scenarios that we described. So this is basically the case which we show in 3 slides, that the car moves from the left to the right. And at some point in time, you may take a decision to relocate also the edge serving the vehicle. So as you see here, that's the starting point. The vehicle has a UPF assigned from the cellular network, and traffic is routed on the N6 interface to the V2X application running on the platform here. This is basically the end scenario. We are on the right side, and in the end, we want to continue serving the vehicle from a new MAC site. The vehicle got a new UPF here, and the V2X application also has been relocated. In between, we try to leverage that DPN overlay on N6 for this intersite scenario to basically keep that kind of procedure as much as possible independent of the 5G control plane. There are scenarios discussed in 3GPP for, I think it's part of a ultra low latency kind of study and description. So here they play a lot with UPFs serving as anchor nodes, as uplink classifiers, and in between they configure a lot these UPFs to direct traffic to the new site. So here, 3GPP side is pretty much relaxed by just adding in another UPF, which can hopefully serve the same UEIP address, and all the relaying we do on the DPN overlay here. So that's something what we investigate, how far this is possible for intra-domain, but also for inter-domain, because the mentioned project, like 5G Carmen, they take a lot of interest in cross-border scenarios, which implies inter-operator handover. So there are a lot of technology issues and challenges underneath for inter-parliament handover, which is not optimally deployed today. But this is something we treat complementary. So whatever we can do on the N6 interface to support that kind of relocation, that's something we want to investigate. So forwarding between the 2 DPNs on top of the UPFs, here we can apply a segment routing, locator rewrite, or even tunnels. And that's something we want to configure then dynamically in alignment with the mobile core decisions. For example, if the mobile core decides on which UPF to use in the target network, an associated loosely coupled DPN need to be selected, and the traffic treatment policies need to be enforced. One last picture here. So for that kind of deployment, in particular, if we talk about cross-domain handover and edge relocation. So in the solution we are investigating, we involve an orchestration layer, because here it's advantageous if you can anticipate that such a movement is ahead. So you can, for example, derive this from the movement pattern and the directions of the vehicle, and then anticipate which network is the best to serve the vehicle in the next 1-2 minutes, and then prepare resources in advance to optimize that kind of process. So here we involve the orchestration layer, and that's also taking relevant standardization effort in ETSI NFV into account, because they look at the inter-domain interfaces between distributed orchestrators. So that's the full system we currently investigate. The IETF part is more on, let's say, the control plane to the data plane, that kind of interface, where we today discussed and refer to the FPC document, or PFCP could also be used here. And on the other hand, between the AF, the application function, and the mobile core, which is semantic, which may be contributed then to 3GPP later. So that's something we would like to describe in the draft. And if these scenarios and deployments is some of interest to you, we would appreciate having more people to discuss with. John?
John? Yeah.
It's also a question for clarification. You mentioned about optimizing and predicting almost so that the policy can be loaded. Is that, I mean, I was considering the latency issue, because in some sense, the policy is being handled via the control plane or management plane, and the traffic is probably 1,000 times faster.
Yes.
So is that is predicting the path the solution to that latency problem, or are you looking at other approaches?
So here we rather look at proactive mechanisms than reactive ones. So as soon or as much as proactive you can be, it helps in reducing that kind of latency. So if you can select a target beforehand, at least some of the resources you can prepare. Some states you cannot set up in advance. For example, if you don't know which access point or the vehicle will attach to. So that's one of the last steps in our scenario that we have to consider. But we can prepare the resources on the Mac platform. We can prepare a selection of UPF and DPN in advance, and that's something we currently look at.
So Marco, is that predicting the path based on historical data or some mobility patterns, or what exactly?
So for that prediction scheme, various things are possible, and that's to be investigated.
Okay, thanks.
All right. Next, similar to last time, we still need to revise the document to focus a little bit more on the actual scope and converge on suitable notation for the first operational aspects and also for the semantics and the information models we want to describe. Still we target a draft update, and if you have comments to improve that draft, we appreciate. And as said, we already have associated contributions in ATC here. Interested in adopting this work, I think we can postpone to a later point in time, depending on your feedback and the interest to progress this document in DMM.
Okay.
All right.
So I think mainly at this point, you're looking for feedback from working group, right, Marco? You're not asking for any action from us, right?
No, but if you have comments or are interested in more details and open for discussion, we would appreciate that.
Okay.
All right.
Yeah, I tend to think this is a very, very good work item. Hope, let's see how it goes. Yeah. Thank you, Marco. Any final questions? Okay. We have two more presentations that were both for Charlie Perkins, but unfortunately last minute he had to do his cancellation. So I think we already discussed about the Yang work item, right, on the FPC also, right? So if there are no comments you want to make on that, Sadaru-san, or okay. So that's nothing else. This is it. This is a closure of the meeting. Thank you, everyone. Thanks. Did everybody sign the blue sheets? Yeah. If not, please come here, sign the sheets. Thank you so much. Meeting is now closed. Come on. That's all.